In this video, we'll be calculating question involving electric field, and the question says two identical charges, 3 microcoulomb, along a circle of radius 1.5 meter at an angle 30 degrees and 150 degrees to the x-axis. Find the electric field in the center. To solve this, let's first of all draw the circle. This is the circle, and we have this as the origin, x-axis as well. This x-axis, and here is the origin. So the first charge, which is 3 coulomb, okay, the radius is 1.5 meters first. And the first charge, which is 3 coulomb, is placed at an angle 30 degrees. Let's assume this is 30 degrees. Here is Q, 30 degrees. And the second angle, the second charge is placed at an angle 150 degrees. Let's assume 150 should be in the second quadrant. Let's assume this is 150 degrees. From here up to this point, if from here up to this point is 150, to find the angle over here will be 150, 180, which is angle in a straight line, minus 150, and that will be 30 degrees as well. So this is the second charge, Q. Now we are asked to find the electric field at the center, this point. So we already have two charges placed at this angle, and they are all positive. And since they are all positive, then the electric field line will be going outward. Let's assume this is the field line for this E. Then another electric field line will be going outward from here as well, because it's positive. This is E. So let me change the color of my pen. Now we have to find the net electric field. But before we find the net electric field, we need to keep in mind that these effects of the charges are being felt in both the x and y axis, and this is in the y direction, right? The effect of this in the y, and let's call this y1, ey1, and let's call this ey2. So there will be another effect for this along the x-axis, and another effect felt on this as well along the x-axis. So let's call this E x1 and E x2. So at this point, we can try to find the electric field by using the vector resolution, and we'll have to make an angle from here. Let's complete this angle. But this very angle over here is vertically opposite to this, so this should be like 30 degrees, right? So, and this very angle as well should be vertically opposite this very one, which should be 30 degrees as well. Completing this, we have these two angles. So now let's resolve the electric field along the x and y axis. So at this point, we can just call this the electric field, total electric field in both x and y axis on this as E1 is equal to the electric field in the x direction ex1 plus the electric field in the y direction ey1. So and this is equal to ex1 is, that is E cos 30 I plus E sine 30 I. So for E2, we have it to be EX2 plus EY2, and this is equal to E cos 30I as well, plus E sine 30J. This should be J, indicating the Y, and this is X axis. But the problem is that what is E? What is the value of E? Okay, let's calculate the value of E. Let me change the color of my pen as well. So calculating the value of E, we know that the electric field E is equal to KQ over R squared, right? So since both of them are the same value, we'll go with this. So E is equal to, K is a constant, which is 9 times 10 to the power 9, and Q is 3 microcoulomb, that is 3 times 10 to the power negative 6 divided by R. R is 1.5, which is 1.5 squared. This same thing as having, when you multiply 9 times 3 will be 27, multiplied by 9, and this will be 10 to the power 3. Then 1.5 square will be 2.25. So when you divide this using your calculator, you have that the electric field E, it's same thing as 12,000 Newton per coulomb. Okay, now since we've determined what E is, then it's left for us to substitute it in this bracket. Okay, but before we do that, let's keep in mind that, let me change the color of biro too. Let's keep in mind that sine 30 is equal to 1 over 2, and cos 30 is equal to root 3 over 2. So you can check all our previous video. We've explained how to get the angles and sines, the sines, cosine, and tangent of quadrants in a different quadrant, rather, in a different quadrant. So since we've gotten all this, so let me switch my pen to red. So it will be easier for us to calculate the electric field, and we've gotten the electric field in the electric field in the first angle to be this expression. The electric field, that is the E2, will be this expression as well. So for E1, we can say that E1 is E, which is 12,000 cos, oh shit, we've gotten cos to be this, so the best is just to use it directly. That is root 3 divided by 2 I plus 12,000 sine 30 will be half J as well. This is multiplication sign. So with this, I can say that E1 will be equal to, when you divide this, you'll be having 10 392 I plus this will be 6000 J. So this is the first electric field. So we have this as the first path. So for the second part, we can say this now. For the E2, now E2 will be equal to, we have to keep in mind of something here, that this, the second charge, which is this, or they actually occur irrespective of the fact that we are targeting this angle, but it occurred at the second quadrant, and at the second quadrant cos 30 is negative. So we have this to be, this is E2, which is same thing as 12, okay, negative now, okay, no, 12,000 multiplied by negative root 3 over 2 I plus sine 30 as well is 12,000 half G. So this is E2 will be equal to E1 here. E2 will be equal to the same thing minus 10,392 I plus 6,000 J. So this is the second electric field. So the net electric field we are after should be like E2. The net electric field, E net or E total, will be equal to E1 plus E2. Right? So we have the E1 to be this expression, E2 to be this expression. Okay, so we have that E total will be equal to 10,392 minus 10,392. This is I plus this and this will be 6,000 plus 6,000 J. So, and this total will be equal to this is 0 plus 12,000 J. So the total electric field is this 12,000 in the direction of J. So that is what's in the y direction. The electric field is in the y direction. That's the net electric field. Thank you for watching this video. Kindly subscribe to this channel for more.